Hey math fans, we're on section 4.3.2. Let's get started. Today we're going to learn about correlation, more specifically the correlation coefficient. Now, the correlation coefficient is known as the letter R, and this measures the direction and strength of a linear relationship between two quantitative variables. Few things to remember. R is always between the numbers -1 and +1. An R value that is positive, in other words, greater than 0, means that it will be a positive association. So anywhere between 0 and 0.9999999, and then +1 is the upper boundary, which is a perfect positive relationship. R less than 0 indicates a negative association. Again, it goes all the way to -0.9999999, and then -1 is a direct or perfect negative relationship. Values of R near 0 indicate a very weak linear relationship. I'm going to go ahead and say if R is between the values of -0.5 and +0.5, we're going to just call that a weak linear relationship. The strength of the linear relationship increases as R moves away from 0 towards -1 or +1. Again, those are the boundaries. The extreme values of R equals -1 and R equals +1 occur only in the case of a perfect linear relationship. Let's take a look at what some of these will look like. Now, please bear in mind that these are correlation coefficients. They're not slopes. I have no idea what the slope of this line is. It's obviously going to be a negative slope, which means that the correlation coefficient will be negative. But the reason why this is -1 is because all the dots are lining up together. In other words, they would be on the line of best fit. As it moves away from -1, this is a -0.8 correlation coefficient. Here is -0.6. Again, they're getting more spread out. -0.4. Now it's starting to look like a snowstorm. I would officially start calling this weak because it is above -0.5. We're getting closer to 0. Here's -0.2, and then here's R equals 0, which there's no correlation whatsoever. Look how close these are. Maybe you could probably see that the dots in -0.2 might be trending down and to the right, but for the most part, when it gets below or when it gets close to 0 like this, we're going to start calling it just weak. Here's +0.5, +0.7. Notice how the data points are getting close to the line of best fit until it gets to, again, a perfect linear correlation. So I like this game. Name that correlation coefficient. Let's take a look at the first one. This is obviously trending upwards as x is increasing, or the explanatory variable is increasing. The y variable is also increasing, and it seems pretty strong. I would say that this has a correlation coefficient 0.9 perhaps, or maybe higher, maybe lower, but probably around there. Let's see what it is. Yep, +0.9. Whereas this one right here is negative, so this will definitely be a negative correlation coefficient. Let's see what this has to say, -0.8. Yes, that makes sense. And the two down here, this one seems kind of weak. Let's see what that one is, but it does seem to be a negative correlation, -0.6. And the other one seems to be positive. Would you agree? Yeah, it's a +0.5. Okay. And here are the last two, -0.2, +0.1. Again, these are very weak correlations. Sometimes applets can be used to try and illustrate what goes along with the correlation coefficient. Here's one where we can start adding data points. And you can see the closer the dots are together, we can see that the correlation becomes closer to 1. However, if I was to put an extra dot, maybe far away from the group, look how drastically the correlation coefficient changes. But if I delete them, look, it becomes much stronger. So the closer the dots are to the line of best fit, well, let's show the least squares regression line. There it is. When you get into AP statistics, they actually have a formula to calculate the R value, the correlation coefficient. But in this class, we're going to be using Desmos. Remember, in Desmos, we're going to be using this format. You'll punch in the data values to a table, and then we will enter in Y1 squiggly mark mx1 plus b. And that will automatically bring up all the statistics, including right here the R value. And as you can see here, the R value is very strong for this particular set of data, 0.99. So what does it tell us here? There's two things it will tell us. It tells us whether or not it's positive or negative. And in this case, it's positive. And then it'll also tell us strong or weak. And then I would say that this is very strong. And that's going to do it for this section. We'll see you in class.